distributed file system really is. A distributed file system is really a way for a system to be able to access data that's in multiple hosts, so it's spread across machines and computers across a network. A very simple example of a network distributed file system is NFS or SIFT or SMB or whatever you want to call it. But that's, more tuned for sharing files than it is for distributed computation. Usually in distributed computing applications like Hadoop, we often use something that's more global, that's more like what I'll call a tightly coupled distributed file system. So one that has a single namespace across the nodes, has multiple initiators, so you can have multiple nodes that are holding the data and multiple nodes that are reading the data at the same time. Some examples, HDFS is actually a distributed file system run this way. PNFS, Gluster, there's several commercial examples as well. Are all available to do this sort of thing.
Question?
Yes.
Can you have an NFS and SIFT on top of it?
There has been some work done around running. So there's one company, MapReduce, that has an NFS interface into HDFS. It can be done for some limited, and I think there's also an open source version too. It can be done for some things, although there's some semantic issues where it becomes difficult because HDFS doesn't really allow randomly accessible files, and it doesn't map exactly to a normal file system semantic. So it can be used for some things, but it's not a general purpose interface. And I'll actually go more into some of those things in the next few slides. So HDFS is a distributed file system, but unlike, usually we think about file systems being in part of an operating system, but in this case it's an application. It's written in Java. It's not integrated at all with the server operating system. So, the files are actually stored in whatever file system's on the box. If it's Linux, it's probably in EXTFS or XFS or some other file system like that underneath. Essentially, you have to go through the Hadoop code to get access to any of these files. Otherwise, they just look like a bunch of random files that don't make any sense. So there is some support to do this through Hadoop. You can do this with kind of libraries instead of having to write a full Hadoop application, but fundamentally you have to go through the Java and HDFS to get any access to these files. It's a shared nothing file system, which means there's no shared storage on the network. Every node is treated as a completely separate set of storage. And one thing I mentioned before when I was talking about accessing it over NFS, it's a write once file system. So when you write a file, the file it can be deleted, but it can't be modified. So you can do appends to it, but you can't change data that's already been laid down on disk. So so it's limited. So the semantics aren't exactly the same as what we typically think of in a file system. Data is organized into files and directories. Just that is like a normal file system. When it actually is laid down on disk, it is in 64 to 128 megabyte blocks. It can actually be, that size is somewhat adjustable as well. And the blocks and the locations of those blocks are controlled by something called a name node. Yes?
Yeah, going back, you said it's a write-once file system, right?
Yes.
So the reason is because we need the data in the future for retention when we are looking at write-once file systems, so we don't want to.
Not necessarily. It's really because the way that they do them, It's really done as a simplification of the file system because it means that you don't have to worry about coherency in the file mappings. It makes it simpler and more high performance. If it was really for retention purposes, you wouldn't be allowed to delete it, and you are allowed to delete files. So it's really more of the trade. There's always trade-offs in these systems of trading off performance for semantics. And in this case, this semantic works very well for MapReduce. So they chose to do this as a trade-off to make it more performant. Yes.
It's layered over a static file system. Can't it be over block storage?
Yeah, and I'll get into it. It runs on a standard file system. It doesn't really care about what's underneath it yet. That's true.
But without a file system, it cannot directly sit above blocks.
No, it can't sit directly on top of block storage. It doesn't have a. It's Java, so Java doesn't know how to talk to raw disks. It assumes there are files. Okay, so block placement is controlled by something called a name node, which is essentially a node in the system that has an in-memory mapping of the location of these blocks of each file. The placement is coordinated between the name node and the job tracker node, so that it can try to optimize. It does it so that when a write is done, it typically is always to the local disk for at least one copy, and when it does reads, it tries to optimize where the reads are at least mostly local, so it reduces as much network traffic as it can. Blocks are replicated in order to prevent data loss. So typically, when HDFS is used, it makes 3 copies of every data block, 2 that are within the rack that server is in, and then another one that's in another rack, so that it can survive rack failures as well. And it's designed, the whole system is designed to be self-healing, so that if there are failures, it can work around them and use the replicas. Yes. Mm-hmm.
Anytime when somebody's trying to make an amendment or some new data into the same file, so they can write the entire file completely again, and
Yes.
then maybe 3 copies of that new file again.
Mm-hmm.
And how do you take care of some sort of, would there be some sort of versioning, or what would it take to identify that this is the same file with the latest data?
It doesn't have any kind of versioning. That would be completely up to the developer to do anything like that.
Quick
Yes.
question. For the replications, so what is the data transfer protocol between the different nodes?
It's built into Hadoop. It's actually, I'll mention it later, but there's a part of the write protocol. It actually, it automatically will have the data write in sequence to 3 nodes. It's part of Hadoop.
And another question is there any compression for the data, or
No, there's no compression.
no compression? It's pure just data.
Mm-hmm.
Okay.
So how does it deal with the fragmentation? Once you delete the file, I'm sure you're getting a lot of holes, right? So is there any defragmented process which runs periodically?
So, the file, they're basically, the chunks are all separate files in the file systems on the different nodes. So when it deletes, if I delete a file, I'll delete all the chunks associated with that file. So really, it's the underlying file system that deals with fragmentation.
So you could have a situation where you have a lot of small files, usually deleted, right? They got deleted, and now you have a workload with a lot of large files. And
Right.
since you have to write them continuously, you may not, even though the space is there, but you may not find the space. So do you have to proactively run the defragmentation on the underlying files?
There isn't anything like that in the system. So for example, if you had a node that ran out of disk space, it essentially wouldn't be it would essentially up being out of the HDFS system, because anytime it would try to write to it, it would get errors.
There's a process called cluster rebalance.
Okay. Yeah.
That you can use to help level out some of those kind of missing fragments.
Okay.
Good.
Question.
Mhm.
So why gets copied 3 times? So 2/3 space is like a west, right?
What's that?
Because the file gets copied 3 times,
Yes.
so 2/3 space is kind of west side.
Yeah, in a sense. I mean, any file system that you want to have be reliable has to have some redundancy in it. And you can, I mean, I'll get to this later. There are other ways, obviously, to get HA that don't require 3 copies. But it's a choice, you know, to be simple and to work on very inexpensive storage versus, you know, working on a more expensive system and one that has other kinds of reliability built into it. And it's a choice, and that's how this system was just designed.
And isn't it true that the 3 copies are also contributing to the packet for the load balancing on the
Yes, and that is another thing, and I think I get to this here, is that basically one of the advantages of it is that you can run, the additional copies can also be used for reading later on. Yeah, so you can actually do computation on all the copies, just like if there's already work going on some of the other nodes.
So is that number of replica constant factor, it will always have 3 replicas, or?
It's a factor that's set when you set the system up. It's configurable, but it's not something you change dynamically. So a Hadoop cluster consisting of nodes the normal way that people use Hadoop is they use directly attached storage. You'll just have disks running a normal file system. The disks attached to the servers which are running the task. And HDFS blocks, as I mentioned before, are run in a special directory within the file system. The blocks just end up being files with names that Hadoop knows. No storage is shared between the nodes, so this disk's only attached to a single node. This is, as I said, the most common use case for Hadoop. It was designed to do this so that it could work on, the replication and everything was designed so it could work on cheap and unreliable hardware and be able to be resilient to that. And there are some very large systems that have been successful with this model. This is how it was originally run at Yahoo. This is very similar to what Google doesn't use Hadoop, but they do something very similar.
So what's the inhibitor for using shared storage?
Well, we can keep going through that. Okay, so let me just keep going with this. If I'm doing an HDFS, I'm going to create a file. I'll essentially go through, I'll figure out where the pieces should be by talking to the name node. I'll actually use an output stream, which is part of in Java, to actually write it. And one interesting thing is that the way that the writing in Hadoop is actually pipelined, so this data node is going to drive the 2 replicas sequentially. So it's not simultaneously writing to all 3 copies, but that's basically how a write operation happens. A read operation, on the other hand, as we were talking about, it's also goes to the name node, figures out the right locations, and it can read it, from any of these data nodes. So as you mentioned, it doesn't have to read it from only the primary location. So the advantage of this, advantage of HDFS using direct attached storage is writes are very parallel. You get access to lots of disks, lots of parallelism in the I/O path. The job tracker tries to keep all the reads local. There's copies, so this is a lot easier to do. And you can you can get a lot of parallel read bandwidth this way. There are some disadvantages too. I mean, as we were saying, a lot of this we mentioned in the questions. You know, it's not a POSIX file system. It doesn't work like a normal file system. If you want to work with other applications, you either have to have some kind of a compatibility layer to allow access, or you have to copy the data off of HDFS to get access to it. The replication costs, as we were all mentioning, are high compared to something like RAID. The name node does have to keep track of all the locations. There is an HA name node support, so a name node's not completely a single point of failure, but it is a bottleneck in the system, and it is a piece that's critical to stay up to be able to keep track of where all the data is. So, some other storage options. So as you were asking, can you run this on? Could you run HDFS on a SAN? So there's nothing that stops you from running on enterprise arrays or any other kind of disk array to run across for Hadoop disks. The system, for example, if I just ran HDFS, but I attached volumes for each of the nodes, the node wouldn't have to know necessarily where that this was shared storage. You could access it just like it was local storage. But you can take advantage of some array features. You can take advantage of the RAID capability in the array. You can take advantage of some of the replication capabilities as well. So in this case, what I'm saying is you take the Hadoop cluster, you attach it through iSCSI or Fiber Channel or any other array network to an array, but to the nodes themselves, it's all still looks like direct attached storage to Hadoop. What's interesting is if you run in this kind of a mode, it is possible to do some of the replication using the array replication, or not replicate if you're not worried about if RAID is good enough for you. And that eliminates some of the need to do all of these additional copies in the system. The disadvantage, of course, is that when we come to read, there's only one place to read the data from if you don't make extra copies. So it does mean there is some loss of parallelism in the reads. So, if you, in this case, as I mentioned, we have some advantages using RAID. You're still using HDFS, so it still is a separate file system, but it does give you, there is some benefit there. The disadvantage, of course, is that cost can be an issue depending on the situation. It's also, there are scale issues. If you may have to use multiple array boxes if you need to scale beyond a certain level. And then also and you still, because it is still HDFS, you fundamentally still have the complexity of having a non-POSIX file system and some of the other complexities of managing HDFS.
Quick comment on the
Yes.
replication part. When we are trying to do the replication between the SAN arrays itself, that can be positive or could be a negative thing as well, right?
Mm-hmm.
If we're trying to, first of all, let's say go back and read the data again, one node is a bottleneck there. Second, if it's not available, then we are relying on that replication schedule and whether or not we have that data back from the other replicated system. So that won't provide the immediate availability, right?
It depends. I mean, it is possible to. So, number one, the question is what failed. you know, if it was the node that failed, you can reattach that volume to another node and have access to it immediately. Although, you know, Hadoop doesn't do that by default. That's something that, but it is possible to do that. If it's an array failure, you know, it depends on how the array is configured, how it was replicated and everything. So, and if it's a disk failure in an array, it probably won't even notice. So, it's possible to run, another way to run Hadoop is to run it on a distributed, a tightly coupled distributed file system. You can actually, if you have one of these distributed file systems like, then you can, that has a global namespace and has all the files exposed that to the nodes, it allows you to essentially do what you did with HDFS, but without, but in a way that is now compatible with other types of applications as well. One thing to think about is, so you can have a distributed file system where the nodes have storage, and you can have a distributed file system where the nodes don't have storage. So think about this like, if I have a filer like in my case, you know, in HP's case, you could build one out of iBricks where it's a cluster of files of nodes. That filer could be talking to all of the nodes through a native protocol where the nodes are separate from that cluster, or it could be running Hadoop directly on that cluster. And I've also saw a talk in SDC talking about doing this with Scality, and there's plenty of other systems that could do this as well. So the question is, so the thing is that you can either have, in this case, you know, you could have your compute. For example, you could have your compute here and your filer nodes here, or you could have it all be part of the same cluster and just run everything kind of the same way Hadoop does. So one of the big differences with this type of a system is that you have a general purpose file system. It's not just special purpose for Hadoop. You can run other applications on it. You can run NFS on it, or FTP, or anything else you want to. It allows you can still use the same kinds of options for disk storage as HDFS. You can run it with shared nothing DAX or direct attached storage. You can run it with SAN storage. It'll work either way. One of the nice things with these systems is that many of them have built-in support for doing HA failover, so you can have an automatically fail over volumes when there's a failure without having to do any additional replication. So in this case, you know, essentially, you would be writing with Hadoop like you normally would, but instead you'd be going just directly through your kernel driver, just like you would with a normal file system operation. And this write may be the local storage if it turns out that that's where it is, and it may be through the network if it turns out that data is on a different node. Some advantages, you know, are that you can treat the data. The data looks just like a local file system. It can be POSIX compatible, and you can use it for non-Hadoop apps as well as Hadoop applications. The distributed file system is going to essentially have its own version of name mapping, so you don't necessarily have to have the Hadoop name node in this case, because essentially the file system is doing that for you. It allows you to do things compute in place. So for example, if I'm moving my data in through NFS and sifts, I don't have to make another copy to get into Hadoop. And this can have, and one of the things that I think I didn't mention here yet was that Depending on the file system, if you have local storage in a file system and you have the ability to tell Hadoop where the copies of the data are actually stored, you can still get some of the benefits around reading data locally as well, just like you do with Hadoop. But the cons, though, HDFS is still highly optimized. It's not, it's not a general purpose file system, and it's very optimized for running Hadoop. So even though you can do a lot of optimizations on a general purpose file system, you probably won't get exactly the same. You probably won't get all the same ones that you get with using HDFS for Hadoop. And strict POSIX compliance that you get in a general purpose file system has its advantages, but on the other hand, Hadoop MapReduce doesn't really let you modify files, for example. So having the ability to modify files in the middle doesn't really help you, and the semantic and the consequences in performance actually can hurt you to some extent. So Hadoop doesn't need POSIX compliance, so sometimes that can be a downside. Distributed file systems, depending on, some distributed file systems have scaling limitations that are worse than HDFS, some don't. One nice thing with HDFS is it is known to work in systems with thousands of nodes, so it has very good scaling characteristics. So I'm probably starting to run short on time, but a couple more pieces to look at. So one of the cases you start to see more and more of lately are people talking about doing Hadoop and other kinds of analytics on object storage. Object storage, is where you access data using a REST API like CDMI or Amazon's S3 or Swift API. They're all based on using HTTP protocol operations. The data is naturally remote because everything is going through a web service call. It's like Hadoop. Most of the object storage APIs are all write once, read many kind of access. They have very similar semantics to what the HDFS does. And the objects have the ability to add additional metadata as well. Data in this type of a system would be stored, as I said, in cloud object storage. You could access it local. It could be a local object storage system, or it could even be across the internet. Object storage tends to be very cheap and high volume. There are ways to, it's usually fairly resilient. It has its own triple redundancy built into it, or erasure coding or some other mechanism. And one way this is often done is there's natively been in Hadoop what's called an S3 connector, and it also works with other systems. There are other systems that have been built as well where you essentially replace HDFS with an interface directly into object storage. So in this case, you have your Hadoop cluster in here. You're running through your RESTful interface to your cloud storage. Let me just go through those. So this has some advantages in that it's very low cost storage. It's high volume, reliable. It's very good location for infrequently used data that doesn't change. There are many places you can put it, including systems that you can buy as well as public cloud options. Object storage is all very designed to be scalable, and it can easily, because it's all accessed through a nice open API, it's very easy to share between other Hadoop and other applications, so you can read the data with anything that can understands the web APIs. Some disadvantages of this system is all the data is remote, so at least for the input and the output files, you're going to have to do remote I/O, so there's no co-location for the reads or the writes. the temporary files would still end up being local, so the performance does work for a lot of people anyways. It has limited capabilities in terms of what you can do to an object, but they're actually a good match for what Hadoop does in its operations. And depending on the system, you know, some object systems, the triple redundancy can be expensive, but as I mentioned, there's systems that don't have that as well. And this, as I said, this can be a very good choice if you have data that's infrequently used, the files are primarily write once, and things that need to be accessed by non-Hadoop jobs as well, so that having an API that's not Hadoop specific is a benefit. So some other options that are emerging, there are actually quite a bit of work going on in both the research community and also companies that are working on Hadoop. One interesting thing is you can look at is having a caching layer where there may be, instead of having 3 copies, having essentially either a caching or replication layer that might interface to a different type of storage system. So caching or mirroring to enterprise storage or to a NAS system. There's also using SSDs. Traditionally, Hadoop hasn't used SSDs because it's a very sequentially, or because it goes through files sequentially, so it doesn't get as much benefit from them. But as people come up with new things to do with it, there's been some work on this as well. There was actually some talks about using things like this in the SDC talks. There's also, as I mentioned, a lot of improvements happening to HDFS. There's better HA for the name node. There's access to, there's some interfaces. There's a fuse interface into HDFS, which makes it a bit more compatible with other applications. There's access to non-Hadoop jobs running over HDFS using special libraries. And the bottom line is there are limitations to HDFS, but there is also work going on attacking all of those limitations. So Hadoop, as I said, it provides a scalable, fault-tolerant environment for analyzing data. It's the default way to store data in Hadoop is HDFS on local file systems, on local disks. There are alternatives to this architecture that are around. I mentioned SAN storage, tightly coupled general purpose distributed file systems, cloud object storage, and so they can provide some significant advantages, but they aren't without their downsides, and so you have to decide the one that's best for your particular use case. And that's what I had to do to present today. Are there any more questions? Yes?
Can you give some examples of this tightly coupled general purpose DFS and the cloud object storage? What kind of solution it is today?
So as I mentioned, I saw in STC there was a talk about Scality talked about doing it. There's also some solutions from some of the other companies that produce storage. There's solutions from EMC. There's stuff that we do in HP. There's several of these where you look at solutions that are built around primarily around the scale-out network attached storage systems are the ones that are using this. That's where distributed file systems primarily are these days. Yes?
Yeah, quick question. Let's say if my organization need to move a 10 terabyte data from San Jose to, let's say, Bangalore in India, for research purposes. Is Hadoop a good system to use on? Let's say every day I need to send 10 terabyte.
is the goal to move it or to
Yeah.
make? So I don't, it's not a technology for moving data, it's a technology for storing and for processing data. And you know, people would disagree with me, but I think as a place to store data for preserving it for future, it's not necessarily the best system either, although that might be controversial. If your goal is so yeah, I don't think that that's necessary, unless if you have specific need to process the data using a system like Hadoop, I don't think that that's necessarily what you want to use.
Is there any plan to add data deduplication to the Hadoop? It looks like it's a centralized storage. Data duplication problem would be a good candidate.
The compression.
I don't know. I'm not